In the last class, we have been discussing about electrolytic capacitors, and I have explained the construction. This figure I have explained. And coming to the advantages, they have large capacitance. The electrolytic capacitors have large capacitance than other capacitance type. And the typical range is from 1 microfarad to 47 millifarad. The capacitance is determined by several factors such as plate area, thickness of the electrolyte, etc. And coming to this figure, you can see the markings on the capacitor. You can see the capacitance value, its voltage, and its polarity. Polarity, this is the negative side, this is the positive side. It's marked negative here. Usually a negative symbol is marked on side. That leg is called as the cathode. Electrolytic capacitors are used in many areas such as filters, time constant circuits, etc. And they are widely used because of its low cost and small size. But sometimes these capacitors get damaged quickly, and the reason for these capacitors to get damaged are listed down as 3, and the first one is due to the excess voltage. That is, excess voltage may cause leak in the capacitor, and this may result in short circuit. And the second reason is due for its quick damage is reverse polarity. Reverse polarity will cause destruction of the oxide layer, and that leads to failure of the capacitor. And the third reason is over temperature. This excess heat will dry out the electrolyte and shortens the life of the capacitor. And these are the 3 reasons because of which the capacitor will get damaged. Electrolytic capacitor may get damaged quickly. And the disadvantage of electrolytic capacitor is, on comparing with other capacitors, is that they have got short lifespan. And this is all about electrolytic capacitors. Now coming to variable capacitors. These are all fixed type capacitors. I have explained all fixed type capacitors till now. It's now coming to variable type capacitors. Coming to variable type capacitor, the first one we are going to learn is air gap capacitor. Air gap capacitor. Whenever capacitance need to be varied, we use these type of capacitors. And the main application of this type of capacitors are in resonance circuits, radio tuners, frequency mixers, antenna impedance matching, etc. And air gap capacitors use air as the dielectric. And coming to the construction, the simplest GaN capacitor is made up of 2 conductive plates. You can see the construction. The simplest air gap capacitor is made up of 2 constructive plates separated by air gaps, and they are used more often because of their simplest construction. And they are usually made up of semicircular metal plates separated by air gap. Okay. One set is fixed. This set of plates are fixed, and the other set is attached to a shaft which allows the user to rotate the assembly. This set of plates are fixed and this set of plates can be moved using a shaft. And here, how can we change the capacitor? We can rotate this shaft to change the capacitance. That is, like larger the overlap, you can see from these figures, you can see this here, the overlap between the plates. This plate is fixed and this is movable using a shaft. And now it has maximum overlap. The larger the overlap between the two sets of plates, the higher the capacitance. And maximum capacitance is achieved when the overlap between the two sets of plates are highest. Okay. See, in this figure, there is separation between the two plates. There is more separation. Okay. The lowest capacitance state is achieved when there is no overlap. And this is all about air gain capacitance. And the next type of variable capacitor is trimmer capacitor. This is trimmer capacitor. This is also a variable capacitor which serves the purpose of initial calibration of equipment during manufacturing or servicing. See, these type of capacitors, users are not supposed to vary these capacitors. It is varied at the time of manufacturing a product. It's not intended for end user interaction. These capacitors are almost directly mounted on the PCB. You can see it in the different types of PCBs. The value of these capacitors are set using screwdrivers. You can see these screws, and the screw is rotated to vary the capacitance, and it can be varied using screwdrivers. And usually it is not done at the end user level. It is these capacitors are varied at the time of manufacturing the product or the PCB only. Okay, due to this nature, trimmer capacitors are cheaper than full-sized variable capacitors. And the application of trimmer capacitors are that it is used to initially set oscillator frequency values, latencies, rise and fall times, and other variables in the circuit. The second application is that if the value drift over time, the trimmer capacitors allow repair to calibrate equipment when needed. Okay, all these come in the service part and not at the end user. And there are two types of trimmer capacitors based on the dielectric used in it. Dielectric is used as air or ceramic. The dielectric used is air or ceramic. Coming to the construction of the trimmer capacitor, they are made up of semicircular metal plates which is fixed where one is fixed and the other one is rotated using a screwdriver. And capacitance changes when the shaft is rotated. You can see the shaft here, the screw here. The screw is rotated and thereby increasing or reducing the overlap between the plates. Okay. To improve the precision of capacitors, simple gear mechanism can be used to allow multiple turns between lower and higher settings. You needn't understand it much, just listen. You have to study a more detailed picture to understand that. The value of the trimmer capacitor is less than, the typical value of the trimmer capacitor is less than 100 picofarad. And these are all different types of trimmer capacitors. And the application is that it's commonly used in radio frequency, very high frequency and microwave frequency band circuits. And these are two types of variable capacitors, and this is all about capacitors. Okay, the two types of variable capacitor, that is trimmer capacitor and air gap capacitor. And that's all about capacitors. So in the next class we'll deal with inductors. Thank you.